Okay, so this video is going to walk you through some of the sketch constraints in Onshape. It's mostly focusing on how it's different from Inventor. So this is assuming you already had some knowledge of sketch constraints from our time together in Inventor. So what we're going to first do is edit a sketch for a cornhole board. So I'm going to show you the worksheet that goes along with this has a drawing of a cornhole board. So this is just a game where you try to toss basically a beanbag through the hole here. And these are the dimensions. So just to see what you have going here, you have a 2 foot by 4 foot board with a circular hole near the top. So if we come over to the document that I shared with you, it's going to, actually, let me get out of this. It's going to look something like this. Now, if yours is not on the cornhole board, just make sure you come down here to the tab and click on the tab for cornhole. And to edit the sketch, we're going to come in here and click Edit Sketch. Now, anything that's in blue means that it is not constrained yet. So we want this circle to be on this midpoint, and we obviously want this this document to be closed here. Now we can hit constraint and bring these two endpoints together. And there you go. So now our sketch is fully closed there. The last thing we want to do is put this circle, basically the center of the circle, on the midpoint of this line. So this is a little different than how Inventor worked with midpoints. There is a constraint here called midpoint. And if you hover over it, it'll explain how it works. You constrain it by picking a line and the point, and it'll put those two together. So I'm going to come back over here and click a point and a line. Oops, and I already had that selected. So let's unselect that. And now I'm going to pick those two again. And I'm going to say midpoint. And it automatically puts that point on the midpoint of the selected line. And that's it. That's how you need to fix this sketch. You can go ahead and extrude this if you'd like, but this is what you need to do. So you can snip an image here and put this into the worksheet. And that finishes up cornhole. Okay, the next part of your constraint worksheet is to edit the charging cube sketch. So again, you can either open up that link I gave you, or if you still have this open, you can come in here to this sketch constraints document and come down here and click on charging cube. All right, so what you see here is this is supposed to be a charging cube for a USB, like an Apple charging cube or so on. And what I have drawn here are the two prongs that would be to go into the outlet of the wall. But this sketch is not complete yet. So if you look at your worksheet, I'm going to scroll down, and here is the drawing that you're going to need. So here are the dimensions that you need. Okay, so with those dimensions in mind, I'm going to open up this sketch. And I like to look straight on, so I'm going to click front view. And you will have to you'll have to add the dimensions that we needed. All right, there we go. I just created a second window so we can see those. So I'm just going to throw those dimensions on there. And what I want you to make sure you do is that you're only going to dimension one of these little prongs. And that's because then I want you to learn the symmetric constraint. So this right here is going to be half of the 44. So I'm going to say 0.44 divided by 2. You can do just like you could do in Inventor. Okay, so that's fully constrained over on this side. Now I'm going to make this bigger again. Now to use the symmetric constraint right here. What it does is it just wants you to pick two shapes or geometries that are symmetric, and you need a center line of some kind. So I'm going to first draw in a center line. So I clicked line, and you click construction line here to make it a construction line, and make sure you get the midpoint. You can see, just like in Inventor, there's a little glyph that'll pop up that'll tell me I'm on the midpoint. So you can see that point in the middle of that line on that drawing there. And now I'm going to pick symmetric because I have the midpoint. And there you go. As you can see, it doesn't matter what order. I can pick the center line first and then the two entities. or vice versa. And now everything is fully constrained. And if I change any of these dimensions, this will change as well. That's it for the constraint document work, but if you carry on, you may need to extrude these and so on. So check your worksheet for that. But this is what I would look for your sketch that goes on the worksheet. Okay, the last thing we're going to do on this constraints worksheet is what's called the tuning fork. It's just the third series in a series of sketch constraints I wanted you to explore. So we still have the charging cube open from before. So I'm going to come down here and click on tuning fork. Now you'll see this is not in any way a completed sketch, but before we dive into this, I want you to see what is a tuning fork. A lot of you may not know. So tuning fork is simply, it looks like this, and it is often used to tune musical instruments. If you look down here, you'll also see it can be used by doctors to test a patient's hearing. So there are a couple of different uses for these devices. So let's go back. I want you to also see what the dimensions are going to be for this. So here we go. There are the dimensions. I'm going to use the biggest dimensions on all of these ranges. So there are different size tuning forks, which will obviously give you a different sound when you hit it. So the longer ones will give you a different sound than the shorter tuning forks. All right. So here is the sketch. And again, I did a split screen so that you can see the drawing and the sketch all at once. All I want you to draw right now for this sketch is the U shape. We're not going to do the handle right now. So let's go into the sketch. Just double click. I'm going to put it on a front view. And this really bothers me here, so I'm going to start by just closing that up. So obviously you're going to want a coincident constraint. And I really don't like that this is not a horizontal line. So there we go. All right, let's start adding some dimensions. We know that A is going to be 50, so A is just the length of this line. Or we could also say it's the distance from that end point to the center. And these are in millimeters, and this document's in units. So I'm going to have to type mm after each one of these. And the nice thing about Onshape is, if you noticed, it just scaled everything so that when I sized this one piece, everything else scaled with it. If you remember, Inventor would leave everything else the same size, and your sketch would, what I would call, blow up or almost explode, and everything would look wrong. So it's really nice that Onshape scales this for you. Let's see, B, which is the width of the leg here, is going to be 5 millimeters. And I'm going to not have you watch all this, but I'm going to come back and you'll see everything's dimensioned. Actually, the last dimension that was left was this 7 right here, because all the rest of this, as you can remember in my work with Inventor before, is I don't want you to dimension these again, because if we say want to make this a smaller one, I don't want you to have to change every dimension twice. I'd rather you just change these. So we're going to set some things equal. So I'm going to make these two endpoint lines equal so they are the same height. And if you remember last time we did a sketch like this, we did this line was collinear to that line. Now there are a few other ways you can do this, but what I want you to notice here, I'm going to make this bigger. What I really want you to notice in Onshape is there is no collinear constraint. We used that a lot in Inventor. The way to get around this, though, if you remember, is that another way, if you don't want to say they're collinear, is you could say this point and this point lie on the same vertical line. So what I'm going to do instead of collinear is I'm going to pick the vertical constraint, and I'll just pick 2 points, and then it'll make those 2 points be vertically aligned. So we did something similar to this before. Now, why aren't these constrained? You may notice that these dots are not in line with the center of that circle, which just means it's not tangent. But if you don't see that right away, one thing you can do is try to move some things around, like I used to tell you to do in Inventor. And now you can see it's clearly not tangent. So you can either make this be tangent, or you can make these 2 line lengths be equal. So I'm going to use a tangent since we haven't used that one yet. And I'm just going to pick the circle and the line, which is pretty straightforward. And now you can see we have a fully constrained sketch. There are no blue entities on this sketch. So you can snip this sketch as well now and turn that into the sketch constraint document or worksheet. So remember, what I really wanted you to do as a takeaway here is that there is no collinear, but you can use vertical or horizontal tools as needed for that. You can also imagine a situation where your collinear lines are not on the horizontal or vertical axes or not parallel to those. So you would have to do a combination of, say, coincident, a point to a line, parallel, that kind of thing. There are ways to work around it. There's just no collinear.